And we might actually end up having to change a few more points this year just because of the price differential.
Hope so.
Yes, good for you. Bad for us. So the scrap man's going to become an important man then?
Well, we're seeing the price of scrap go up now.
Yeah. I know it must have gone up because the local company to me took my skip away, said I wasn't frequent enough, and now I've got it back.
Yeah.
That would explain it. That would explain it.
We were the first company to do the lady shaves back in 1908.
We've all got a lot to thank you for then.
Yeah.
It's the 24th of March. While the weather's turned a bit poor on us, we've shot up to Sheffield, back to one side of my family's roots. I'm with Ian Lane, and we're at Chapmans, and we've come to see with Paul Bray at Spaldings, just come to have a look at where the wearing metal is coming from with the season coming up, and actually what effect the war is happening on the terms of us, what's going to be in term coming to supply on the farm, what's happening in Ian's life. We probably haven't really thought about. We're complaining about the fuel prices and fertiliser, but actually the knock-on effect for these guys, because they are energy based in terms of electric and gas, and then the steel that they're producing to make our points and things to make agriculture. So got some alarming figures out of Ian earlier. 50% increase effectively in the gas price, and we were just talking about the tungsten. And just tell me what effect on tungsten have we had?
Tungsten is 3 times the price now.
Yeah, so in the 4-week period we've been in with the problem in Iran, the knock-on effect that they're making now to effectively arrive on farm for us to have it for the summer. So that's a massive increase.
Massive increase. And then the other problem we have is, will we actually get hold of it? Will we get the supply?
Okay, so that's the next thing. So basically this is a panic buy program, isn't it, Paul?
What I think it is good is just to highlight the pressures that British industry is facing at the minute. But also it has a knock-on effect for ourselves, for you as an end user.
Yeah.
And I think it's also going to be interesting for you guys to actually see how the products are made.
Yeah. And the association with Spaldings and Chapmans is 35 years plus. So this has been a long-standing relationship of making manufacturing parts, which we're going to have a look at. But just an example, Ian, what would be made here that would actually be on farms that people would be used to seeing?
Well, if you've got a plough, any part on the plough would be made here, somewhere over here on the other side of the road. If you've got a cultivator, you've got a subsoiler, anything like that will be made here.
And this factory has been on the go since 1948.
1948.
You bought the business, did you say, in 1980?
Yeah, well, we started out in 1982 in a small place, and then we bought this building here and gradually grew from there to owning most of the sites as we see now.
Yeah.
Just been steady growth nearly all the time.
And then you sold out personally 2.5 years ago.
I sold out 2.5 years ago.
But they wouldn't let you leave. So you're
chairman.
You're chairman.
Chairman.
So you haven't been able to go off and have a luxurious lifestyle in the south of France.
Unlike some people.
Yeah. It's what I dream about. Every time I get there, I'm going to be too old. That's the problem. But anyway, I have a good dreams at night.
Yeah.
But so this is actually for me. This is quite nice to be here because this stuff is on my impress stock, isn't it, Paul?
Yeah.
My shelves are full of products coming out of Chapmans, but I wouldn't know that.
No.
Interestingly, because they're not badged as Chapmans,
No.
not badged made in Sheffield,
Yeah.
so they're badged as Spaldings, or it may be products which are actually being made for original manufacturing.
Yes.
Which
yes.
you're making, then sold in original manufacturing colours and stamped.
Yes.
Again, making it to my shelf.
Yes.
But you're quite clear that you have a very distinct line change between stuff that's going to Spalding, stuff that's going to original manufacturing.
We do not have 2 bites to the cherry. We only have 1 bite.
Yeah.
That's the simple rule.
So if it's an original manufacturer, they have that. Spaldings can't access that.
Correct.
Yeah.
But
Correct.
we'll get manufactured to exactly the same specification, hardness and tolerance. If we have to change something, we change something. But it's been a very clear understanding from day dot, hasn't it?
Yeah, absolutely.
That's why we operate.
But you're quite proud of the fact that it's quality that you're actually putting on people's farmers' shelves coming out of the factory here.
Absolutely.
I'm looking forward to going round, so it's going to get hot in there, isn't it?
That's what's important to us.
These are Lemkin points, forged here yesterday. So these are now just being hard faced. This is pre-hard facing.
So just interesting, what is this actually made out of?
This is made of a 30 carbon boron. It starts as a round and then it's hit 3 times into the shape, clipped. And
we're going to see this being made somewhere, are we? Or something
You're going to
similar?
be something similar.
Similar, okay.
Yeah.
Yeah. But this guy over here, what's he doing?
He's hot. I'll show you one. Morning. Are these warm? Okay. So we're hard facing these.
Oh,
this
what?
Is another long life product.
What, as in like hard facing, like we would do in the workshop?
Yes.
Okay.
But it's obviously a special alloy of hard facing of material.
Yeah.
So this will probably double the life of the product if this wasn't on.
Right, okay. So, and this is actually a range that you would do, or is this what Lemkin wants you to do?
This is for the aftermarket. We don't make the Lemkin.
Okay.
So this product is sold probably to Spaldings and similar people in Germany.
And you were just explaining to me earlier that there is now going to be a problem potentially getting hold of tungsten, and so that do you think that you'll see more of this next year, more so than we will on tungsten points?
I think if it continues, the farm will have no choice because the price is just
it's going to be
no
pushing.
Benefit.
Yeah, we'll push it past the economic stage.
Exactly.
Okay.
So I think probably the cheaper, longer life coatings, which you'll probably see later on, that probably will play into our hands.
And we might actually end up having to change a few more points this year just because of the price differential.
Hope so.
Yes, good for you. Bad for us. So Ian, what are we looking at?
Now is about to drop down, so that's a 50mm round billet, we call it.
Okay.
Which is
oh wow. What temperature has that been heated to?
Around 950 degrees.
So you're buying those, are you, in that form?
In long lengths. So now we're going to see the 5 degrees, that's 1 hit.
Wow. Wow, and that's just compressing that into a mould.
That's compressing all the steel into a flat
What sort of tonnage is that?
Well, this is about the equivalent of 2,500 pounds.
Wow.
Pressure comes mainly from air. And that's got the shape. So the guy takes it over to the other press. What they're doing now is clipping the excess away around the edge of the profile. Yeah.
Oh, and that's what you've got in this bin?
That's what we call the skeleton.
Oh, I see. So what do you do with that though? Is that wasted?
That's scrap.
Is it really?
Yeah.
You can't reuse that?
No. Well, it does. It is reused. We sell this at about 250 quid a tonne for scrap. It goes back into the steel process.
Oh, okay.
So the robot is here.
Yeah.
So he's picking what we call the billet out from here. So you can see he's got magnetic clamps on there. So he's waiting now to drop it onto the production line. This is the whole induction heater here.
What, just in those boxes?
Yeah, that's the electrical.
And what is that? What is causing
the
heat?
induction? So it's basically heating from the inside of the steel outside.
It's like a microwave, basically.
Yeah, like a microwave.
Okay.
Yeah.
But where's it getting its power from? From the electric?
From the electric.
Okay. Is that a limitation in expanding a factory for you to be able to have enough gas and enough electric?
Definitely.
So have you had periods where you've actually struggled to grow because there hasn't been enough of the two main sources?
It's been a bit tight now and again, yes.
Yeah.
But there's less manufacturing going on.
Oh, did that release you more capacity?
We're using more because people are no longer in the region.
Okay.
In this particular area.
And you've got a lot of good skilled people in Sheffield, I would assume, to be able to employ.
We have a huge infrastructure of both people and services.
Yeah.
So anything that needs repairing, it's fairly easy for us to find that contract for repair it quickly and easily for us.
Because it's a culture around here.
It's the culture.
Interesting. So that actually makes Sheffield a very good manufacturing place.
Oh, I would say we're one of the best in the country in
really?
terms of the infrastructure and support we get.
Amazing. So robotics, is there a lot more? It's so loud. It is. I mean, you can feel it. In robotics, do you think there's more you could do with robotics?
Yes, we have a lot to do. So this is the first robot we've put in, and the idea is each year we'll start to put a robot in each production cell, probably just to load the cell rather than to use it.
You're getting it to basically take away the manual work.
Yeah, to do this, we use the robot to load the cell, so it's pushed through the furnace.
Yeah, probably more safe. And this guy here, is he running the robot basically?
No, he's not. He's creating the program.
Okay.
Because we're just fine-tuning it today. For instance, yesterday we were running it without him, and it kept stopping at the end of each of the lines.
Okay.
Can't quite work out why.
So you're now having to find new people with new skills that you never had before. So you solve one problem and it creates a new problem. Yeah, interesting.
These are for the muck spreaders. So the customer welds left and right together to create
the spiral.
The spiral.
Yeah.
So all these are hardened parts.
So this would go on, say, I don't know, Bunnings or a Richard Weston muck spreader or something of that order.
Yeah, I think these are Bunnings.
And then these machines, I'm assuming, are going all over the world, are they? To go
America, Australia, South Africa, you name it.
And so that part, do you make the shaft as well?
No, we don't. No,
so you make this part, and then that goes to them. They weld that on.
Yes.
Okay.
Yes.
And what's so special about these?
Well, these are through hardened boron steel, 30 carbon. So compared to unhardened part, these will probably wear 5 times longer than the hard steel. 5 times.
Oh, and it will take the abuse of rocks and things like that.
Yes, they don't bend. The customer now has no problems with stony conditions.
Yeah. And how did you end up getting that contract?
About 18 months of painful development.
Oh, really?
Yes,
to try and design it to make it work?
Yes, to make it work.
And to develop that, I'm assuming you draw it on a CAD, but then was it going out onto the machines to actually trial them?
No, we did what we had. The customer sent us up a long tube, the axle effectively, and then it was just trialling on the machine on and off and trying to work out how we stop distortion. That took us about 18 months to do on and off the machine.
Oh, what? Because the heat was altering the angles?
Well, the heat would cause a problem with, because obviously it's really important in a spiral that you have the flow of the mule going through, and if we didn't get it consistently right, it would stop the natural flow.
Yeah.
So, but we solved that. It took time, but that's what we did. And now we just produce thousands and thousands of these now. Happy customer.
Hopefully happy farmer.
Happy farmer too. In the old days, this would be full of bars of steel. So all the steel comes in, 2-ton bundles.
Yeah.
And we have a minimum order of 10 tons.
Is that how they do it? They wire it up to weight?
This is Spanish steel, this is Swedish steel.
Okay. They're the two sort of places that steel generally comes from.
Well, certainly for us, yes.
Yeah.
And so we now have just-in-time deliveries.
And Port Talbot is closed, so you can't get anything from there.
No, closed.
So that means you've had to go internationally to get your steel.
Yes.
And does Sweden, for example, I wouldn't think of Sweden and steel, but do they have a roaring business over there in steel?
They're very big steel producers, big steel producers.
Right.
And very specialist, because that's what we're looking for. We're looking for high quality, consistency in our supply chain. You can deliver on time, good price, but also high quality.
So now that you've got a war, have you got a problem with steel coming from either of those two countries?
Not on terms of supply, but definitely in terms of price.
Oh, so the price has jumped?
Is jumping up.
Oh, right,
daily.
Continuously. Okay.
Because the biggest cost in steel making is now energy.
Yeah. But energy, is it as bad in Spain and Sweden as it is in the UK?
We've probably got one of the highest costs of energy within Europe. moment. So it's more painful for us because we've got so many government levies to develop nuclear and also to decommission the old nuclear plants.
Yeah.
So we've got quite a high, let's call it duty or tax,
Yes.
on what we pay, particularly for electricity. So it's painful. But yes, it just leads to a lot of uncertainty.
So to something you told me earlier was that the UK uses 10 million tonnes of steel annually.
Yes.
And it has the ability to produce, with current infrastructure, 5 million
5
tonnes.
million tonnes, yes.
So there is a natural deficit that has been fulfilled from international...
Yes.
Okay.
Yes.
So we actually can't be completely... Well, we would if we built some more factories.
Well, they're talking about now building a big plate mill, because when we build a lot of these nuclear reactors, it's going to be the future.
Yeah.
We are not doing much towards that in terms of steel. So the idea is to build a plate mill to do the very thick sizes, sort of 50, 100 millimetres thick. That's the plan.
So you'll have deliveries of steel coming in all the time?
Yes. Yeah, we're certainly the first 2 weeks, it's every day.
Oh, really?
Yeah. Well, it trickles in. It's easier for us to cope with. We don't want everything coming in all at once.
No.
This is where we paint the product.
Oh, so painting, so this is your dipping tank?
This is the dipping tank, so it's like 5 or 6 colours.
Yeah.
And the customer chooses what colour he wants.
So these guys are putting the materials on the racks, and then these are just going along and then dropping in, coming back up. Do they go to get baked or heated or something?
Yes, there's a baker behind here. It sort of goes round on the rail into the oven.
Yeah.
Baked at about 180 degrees.
Okay.
And then cooled off. Down here, by the time it comes off the line, it's obviously dry for the guys to handle.
Okay. Not too hot either.
No, it's usually, they've got cooling fans.
Okay.
A lot depends on the ambient temperatures outside.
And that is effectively a finished product.
Yes.
And then where does the quality checks happen?
Quality checks, we have a final inspection check.
Yeah.
So before it's sealed up, we have a guy who comes to check one, probably in a pallet.
Yeah.
And he'll just do a vernier, but most of the checks are done during the production process.
So we've got a G there. I think it's a G.
That's
Yeah,
G.
Yeah, it is a G.
A G, that's aftermarket.
Okay.
These are all aftermarket.
Right. And that colour was out of Kverlen colour.
Yes, that's Kverland.
Yeah. Okay.
That one I think is Kuhn.
Okay. And is that going to get painted, or does only the OMs get painted and this?
No, everything's painted unless the customer says don't paint it.
Oh, really?
Yeah.
Yeah. Just to stop it going rusty.
Yes.
Yeah.
Appearance is.
Yeah, I suppose at the farm,
reasonably important.
I don't want a rusty old ploughshare.
Well, if you buy a new car, it doesn't turn up full of mud, does it?
No, that is true. It does a week later.
So everything is packed and put away.
Oh yeah, you got all the great houses in here, haven't you? Yeah.
There's not many.
Yeah.
There's not many. We don't.
How many customers would you have?
We've got about 120.
Oh, a lot. All in agriculture.
Yeah.
Cool. You wouldn't think there was 120.
Well, go around Agritechnica and it's fairly mind-blowing to see
how many there are. Yeah. And you're not just supplying UK-based businesses, you are also supplying businesses in Europe?
Yeah, we're about 40% into Europe at the moment, 35-40, depending on how things go. But yeah, we've been exporting, we show at Agritechnica.
What about outside of Europe? Are you going internationally?
Well, we were doing quite a bit into America until we had Mr. Trump's tariffs come in. So we've now got 20% tariff on their duty, and I think the demand will slow down a bit, unfortunately. It's frustrating.
And what about in somewhere like Russia?
Well, we're not at the moment we stopped selling into Russia because the UK clearing banks don't talk. There's no system for them to communicate between UK and Russian banks.
Okay.
So unless we were to get paid by a third party or by another legal entity, it's very difficult for us to supply in there.
Yeah. Because I mean that is a big country for agriculture.
Huge.
Yeah. So I mean, effectively, that will have obviously caused you some kind of pain.
After the war, we dropped to about 12% turnover because of the war.
Wow.
Because there's Belarus, can't do with them.
Yeah.
Ukraine is more difficult, although we are selling to Ukraine, but not in the volumes that we were.
So you're still got to keep everybody employed. You've still got to keep the lights on. 12% is a big drop.
It is a big drop.
Yeah.
But we've managed to replace it.
Yeah.
Go and find other customers in other countries. Yeah. But we're back growing again. That's the good news.
Yeah. You want growth.
I want growth.
Yeah. So it's getting noisier now. So getting back into manufacturing. Where have we got to now, Ian?
So this is the main engine room of the factory. This is where all the heat treatments and press work is done. So when we walk round, the whole of the factory is networked in terms of water, which is what we use in heat treatment to cool the product as quickly as we can, which is what gives it its hardness, because you're changing the microstructure.
How many times did you heat it up and cool it?
Well, ideally once, that's it. But when we're forging, we do it twice.
Okay.
Because we lose too much heat during the forging process. But in here, we've probably got 12 production cells that use 2 or 3 mechanical presses that make the components. So the operator walks around, puts it into each tool, and then it goes into heat treatment automatically.
Okay. A lot of equipment in here, but it's all blue and yellow. Have you painted that, or is that one make?
No, when we had the fire, we repainted all this, part of the recovery program, repainted, house colour is blue.
Okay.
So all the presses are blue, and anything that was important, health and safety wise, we painted yellow to highlight it.
Okay. And how is this 950 again?
Yes.
Is that the heat that you need to make it?
Well, we set them at about 1050, so they come out at 950.
Okay, yeah. And then basically pressing it into the shape that you want.
This is the water I was telling you about. So what we're doing there is holding the component within the tool to stop distortion.
Oh, so it's not pressing it, it's just holding it?
Just holding it.
Okay.
So if you put one of these parts in without that tool, it wouldn't come out like that.
Oh, it would
come out like a banana.
Shape. Okay.
So you're going down from a temperature of about 900 to lukewarm in 20 seconds.
So do you put the holes in afterwards?
Well, on this particular component, the customer, this is what they call a bolt-on part, and they have like assembly welded on the fabricated assembly underneath, and that just sits on top.
Okay. Oh, I see.
Let's
So
go to a customer in Holland.
Oh, really?
Yeah.
So he loads one in and he takes one out, and so on.
Yes.
Okay. So it's just like a bread oven then, he just keeps doing that.
And the nice thing is that the furnace feeds the man doesn't feed the furnace.
Yeah.
So for all the production facilities we have here, you'll see on here these little platforms on the floor. These are scales.
Yeah.
So it's measuring the weight. So every time the guy puts a part into there, the scales will measure. In fact, the weight of the whole cylinder has gone up. So this is like productivity.
Oh, really?
Yeah. So we have scales everywhere in the factory. It's called a data retrieval system.
So that's how you do it, through the weight.
So all the time these guys are measured. Everyone's measured all the time.
Do they get a bonus based on output?
No, we stopped doing a bonus because it doesn't lead to high quality levels. Because people start to rush.
Oh, okay.
And they don't respect
the
quality standards of the parts.
Right.
So we stopped doing that, and they don't now longer get a bonus because we didn't think it was fair, particularly guys at my age They can't keep up to what they used to produce 10 years ago.
Yeah.
So we just thought it was fair. But they're all monitored, they all have their own private dashboards of how they're performing.
Oh, really?
Yeah, every single person has a dashboard.
What, and can everybody see it?
No.
Oh,
Each
individually?
person,
Okay,
the guy who's in his CAD and his boss CAD, but not everybody else.
Okay, got it. Amazing.
I wouldn't want everybody to know what I'm producing, put it that way. This is what I was telling you about. The water is pumped, completely networked, it's up in the ground. Well, we've got about 4,000 litres of water sitting there.
From the roof?
Down below.
Yeah, does the water come from the roof?
Yes. No. We have to top up every day.
It's made.
It has to be clean, so we could filter it, but that costs money.
Yeah.
But basically all this is pumped into here. We're measuring the temperature of each cell with water. It has to be a certain temperature, so we control the water in every tank, plus or minus 2.
Where's the wastewater go?
Where's what?
The waste.
There's no waste. It's just continually going round. So the only waste we have is through evaporation.
Okay, yeah.
That's why we top it up. But it's
And that's a rotavator tine, is it?
That's a flail, potato flail, goes on, that cuts the heads of potatoes with the
Really? Okay, yeah. What's that?
This is the Durafacing. We don't call it Durafacing, the scholars call it Durafacing. We call it Architect. And this is the slurry side coating we were talking about earlier. So this gives the line, extra line, about 2.5 times uncoated. So here, we'll show you later where we actually put this on. This is going through the final heat treatment stage now. And this is the key benefit of this process, is that we heat treat right at the end.
That's been put on. He's now putting it back in the furnace.
Yes.
And then he's putting it back in the water to cool it. So this is a hardening stage.
Yes, that's the hardening.
And that's hardening the slurry, basically.
Yes. Well, it's hardening the parent section as well.
So how do they put that on?
I'll show you later.
Oh, okay. And then when he's done that, is that a finished product?
Yes.
Or will that get painted?
This will be shot blasted, corner, and then painted, what you saw earlier.
Okay. But there's a lot of manual work in this.
A lot of manual work. So all these colour codes tell you what's going on.
Yeah.
I like to see the green. I can never tell the difference between green and yellow, but I want to see job running.
Yeah. You know you're making money when it's all green. Yeah.
I don't want to see red.
You don't see red, no. Shut down.
Okay. So here is the horizontal board. What we're doing here is forging the end of the converter chair like that.
Oh, I see, yeah.
We only heat up the front nose to begin with.
Yeah.
And then it goes into a second heat, which the man here loads to be finished off in another cell next door.
Right, so he heats it on that,
Yeah.
puts it into that presses it.
Then he punches the holes.
Punches the holes.
And then puts it on. The man loading it, he or him loads the...
Right, this is for hardening.
Yes, so this is what we call a walking beam furnace. So you can see it just as it's sort of going like that. So it moves it on about 50 millimetres at a time. So it's self-loading really.
You don't look like a guy you want to fall out with. That's a big boy.
It's a big boy.
That's a big boy.
Deliberately chosen, by the way.
Is that your debt collector?
Energy used to be 350,000. Now it's over double.
And gas?
Well, that's both gas and electricity. But there's no way around it. The parts have to get to this temperature.
Yeah, you got no choice. In terms of operating hours, is the factory 24 hours?
Yeah. During the week, yes, we're 24 hours all the way through.
So you've got a night shift team, or you've got 3 teams?
We've got 3 teams, morning, afternoon and night.
So 8 and 8?
No, we do 6. 6, 2, 2, 8, then all the way through.
Oh, sorry, I meant 8 hours, 8 hours, 8
yes,
hours,
yes,
sorry.
yes, sorry, yes.
Yeah.
Apart from Friday.
Yeah. And then do people have to move around? So some have to do the night and then do the day, or
no, we tend to find the night men like to do nights.
Yeah.
Whereas the morning and afternoon shift, 1 week you're on a morning shift, the next week you'll be on the afternoon shift.
Okay.
Most people would prefer to do the morning shift.
Yeah.
Because you've got the rest of the
Rest of
day
the day
off
to do whatever you want. Yeah.
After the hardening process, we do the tempering process, which, as it sounds, is the way of chilling the microstructure of the steel. And it's really important we get airflow. So when they set these, we put a gap between each one to ensure the heat flows right across the product.
So it comes out flat, and now you're going to shape it.
Yes.
But it's so hot, that makes it look so easy, doesn't it? Yeah.
What it's now doing is going into the water pit. We're forcing water onto the parts. Again, it's about a 25 kilo part. We've got to make sure we cool it in about 20 seconds. So we have to force water through the tooling to ensure we've got the 20 seconds. Heat treatment is the first part of the cooling process. We need to get it down within 20 seconds to below 300. That's all we have to do, then we don't mind after that.
So you'll take it out of there at 300 C?
No, we'll come out at about 60.
Oh really?
Yeah. They may even be able to handle it.
I'm assuming this is measuring the temperature, is it?
Yes.
Is it fully automated then? Will that come up when it's ready?
Well, we built all of this ourselves, the whole unit.
Oh really?
Designed and built it with the help of the university.
Which one?
Sheffield.
Oh really?
Yeah.
Why, they've got a very good engineering side at Sheffield University.
Fantastic engineering, absolutely fantastic. And we worked with the AMRC, which is the Advanced Manufacturing Research Centre, on the other side of the city, basically to do all the modelling, because what we're worried about is have we got the strength within the whole structure of the machine to cope with the forces involved here. And it took us about a year to convince
This is part of your 18 months trying to get this right. When you say 18 months seems a long time, but when you start to see some of the kit you had to build.
Well, of course, the trouble is when you're developing a new product, this is also needed for production. So we can't spend 1 day a week using this machine. We say to the production manager, look, you can have it for 3 hours.
Yeah.
After then, no. It's got to get back to production.
You've got to pay its way.
And this is the problem. That's why it took so long.
Is that the slurry you talk about?
Yes. So we buy a powder with a secret formula, chemistry. And then we add water. And then a bit like making the icing on top of your cake. So we make all that. We do a couple of tests on there. We hand dip it. And then it goes through an atmosphere controlled furnace. Through a walking beam on a melt.
No, but is he dipping that just in there?
Yes.
It's crude as that?
Yes. Well, all that's doing is just stirring it up. Because to us, so we've added tungsten in there, so it's important we have a uniform structure of the coating. So all that's doing is making sure everything is consistent and evenly spread. So it goes through, each box has a different atmosphere. So then there's the cooling one. So it goes through 3 different types of atmospheres, then finally to the cooling process.
So we get to the other end, it's coming out. So that's now baked on?
Yes.
So is that going to give it 5 times more life? Or?
No, this will probably do 2.5 to 3.
Okay. And cost-wise, for the farmer buying that, is that like 1.5
I would say
times?
they probably get 1 life free.
Okay, yeah. And you're making your saving not only the life, but it's also the time in changing.
That's the key, really, is the time.
Yeah. I've actually never seen it.
Oh, really?
No, I've never seen it.
There's no easy way. You have to be prepared to work with the customer to find out what's the best type of pattern to help the wear. So
what do you call that? Is that the Duraforce?
They call it Durafacing, yes.
Durafacing.
They have their own slight recipe that they have, which we work to. We have our recipe. But in principle, we have to develop the pattern of the coating for each product.
Yeah.
So the first thing we'll ask for is, please send us the partly worn component so we can have a look at where the wear is starting.
Oh, clever.
And then we say, give us a fully worn one. That's how we start the development.
So, did you develop this?
Yes and no. This actually is an American coating.
Okay.
That was invented by Ingersoll in the States, mainly for this. And it came over here, and the company who was doing it eventually sold the plant to us. What we've done is refine the recipe, both of the powder and the processing there, to make it more effective. That's what we've had it for nearly 30 years.
Oh, long time.
Long time. But
I'm assuming the reason I haven't physically seen it is because I always seem to get the tungsten material.
Yes.
So that'd be why this must be an alternative one, which
it is. But it's all a question of what you're prepared to pay for. You know, not every farmer wants to spend something 5 times the normal cost of his normal uncoated parts. Some farmers will pay maybe double, but they don't want to be paying much more than that.
Yeah.
So it's horses and courses.
Does this work better on sandland, for example, than tungsten? Because you know how you can get it wearing in the wrong place, and then the tungsten falls off.
Yes.
So you actually never got the benefit of tungsten.
Well, I think with tungsten, I mean, we do have a tungsten brazing process, but again, it's difficult because we know that the raw tungsten that is brazed onto a component, if that goes into heavily stony conditions in the field, it's probably likely that the tile could chip or even come off.
Yeah.
So this is where this is quite good.
Yeah, okay.
Because it won't chip. It'll wear, but it won't chip.
So you never get the full value of the others on the wrong land?
No.
Yeah, that makes sense.
The farmer knows his own land.
Yeah.
So he just has to take a choice. Earlier you saw us with the bar product steel at the other end of the site.
Yeah.
This one is what we call hot rod coil, which is then cut into lengths. This is what we call the skeletons. I always like to see this because there's hardly any waste on here at all.
I'm assuming you've got people trying to work out how to maximise the amount of steel that you actually have delivered to go to
Yes.
the stage before it breaks and fouls you up.
Yeah, all these would be, so we have a template that the designers have to use. So here will be a set gap. Maybe, I don't know what thickness this is. This is probably this is 12 mil. So you're supposed to have 1.5 times the thickness between each piece.
And then this is just going off to the scrap man, and then they're doing whatever they do with it.
Well, this eventually will all go back into the steel mills, because all the steel mills are becoming now scrap-based electric arc. In the old stage, South Wales, which is currently closed, that was iron ore based. Now they're building a new mill which will be based on scrap. So they put the scrap in a big pot, and that's how they start making the steel. This is what the general feeling is are we losing the art of steel making? But of course, to go use an iron ore based route is very expensive and a huge cost on infrastructure, particularly with the energy side. So this is the way the market's all moving towards.
So the steel would come from abroad.
Yes.
You'll make your product.
Yes.
The scraps then go into a melting pot, basically.
Yes.
To remake sheets of steel.
Yes.
And then they're back out to industry.
Yes.
So it's basically we're making that 5 million you spoke about. Is that based on the scrap or is that based on iron ore?
It's a good question. I would say I can't because I don't know.
They don't break it down like that.
In the UK, we've been traditionally iron ore based.
Okay.
At Scunthorpe and at South Wales, but eventually I believe it will all change to scrap based.
Wow. I didn't actually even know that happened.
Yeah, that's the way it's all going. All going.
Right. So the scrap man's going to become an important man then.
Well, we're seeing the price of scrap go up now.
I know it must have gone up because the local company to me took my skip away, said I wasn't frequent enough, and now I've got it back.
Yeah.
That would explain it. That would explain it.
It's going up by the day.
Yeah.
We'll go and have a look at. So this is the pieces that come out, and the great thing about laser technology now is it's so accurate.
And you haven't got sharp edges or anything.
No sharp edges. There's no burrs. Or
so it effectively makes you a clean piece of metal.
Absolutely, and accurately.
Yeah.
So all the whole positioning is absolutely perfect.
And what creates a laser? This isn't air, is it? This isn't using.
It's basically through electricity, isn't it?
Right.
And a gas.
Yeah. So there is actually a gas involved as well.
Yes.
So it's effectively like
That's
the plasma.
what it runs on. Yes.
Yeah. Okay.
As usual. So there's something like 500 pallets of tooling here, which are all barcoded with and positioned up where they are. But every job, 90% of the work we do here, has got to have its own tools.
Did you make the tools, or
we make it here.
Okay, so you have to have some guys who, if you get a new product line.
That's what you'll see later. But yes, all this is designed and built here. Everything.
Yeah. Yeah.
And that's always the issue for the customer, is he's got to invest in the cost. Say on an average
Startup
cost. It's about 2.5K to make the tooling for an average job.
Yeah.
Just as a
So he's
rough
got to
guide.
have a proper run through of stuff to pay for it. Yeah.
But the OE are very good, because if they believe in the product, it's going to work, they'll spend the money and they'll do it.
Yeah.
So it's an investment, really.
Yeah. So all of these pallets here, if you get out of the 120 customers you've got, effectively you've got a box related to them. Yeah.
Sometimes many boxes.
Yeah, I can believe it.
So we set this up especially so you can see the process. But the problem is we've run out of braze.
So where do you get the braze from?
The braze comes out of Germany, but it's a global product as usual.
And what's braise made out of?
Well, it's a recipe that we keep secret.
Okay, yeah.
So I can't answer that. But there are two key elements in there, one of which is... Oh. Thank you.
Is this the braise?
Yes. Well, it is...
So the braise is effectively your super glue.
Yes.
All right. Which Granny invented, no doubt. Yes. Okay. Does it have more than one?
Yes.
Okay.
There's two different elements.
Okay. So that these strips are also tungsten, are they? Or they?
No, this is the actual braise material itself. There's two different elements. So here we're using induction heat to melt the braise. Just see it now. So this is what we call a coil. It's in the shape of the part.
Okay, yeah.
So this is heating it up now.
So the very thin strip is melting, is it?
Yes.
And that's bonding the bottom and the top? Okay.
Yes.
Oh, it really is getting hot now.
Yes.
Again, this is quite a time-consuming thing to do, isn't it?
It is. I mean, that's one of the issues here is we also have to machine the pocket that the tile sits on. So we do that for a number of reasons, and that's to make sure the tile doesn't fall off, and also that the tile seat is absolutely flat. You can imagine if the seat pocket was like a radius on it, it would eventually fall off.
So if you get a tungsten where it falls off, it can be that the brazing effect has just not been done correctly, and it could be a number of factors. Still not shot blast right, it's got oil on.
I mean, it's a long time. When we were first developing this system, maybe 15 years ago, yes, we learnt the hard way.
Yeah.
And we did have tiles falling off. And we kept on working out why and how. Eventually, you keep reducing the number of risk levels. And I can't remember the last product we've ever had back here in 10 years. That the
Okay,
tiles
so
have fallen off.
you've got it right now.
Can't remember. We've had a few back because they're chips, but probably because the farmers go through very stony land.
Yeah. Sitting something. You can't change the nature of the tungsten, I'm assuming.
Really.
No.
Well, you can. You can actually, because then you've got the issue is that the farmers who are in sandy land, who have no stones, for instance, they don't want the grade of tungsten, which is really for stony land, which is slightly softer. So generally speaking, we have to steer the middle course.
Oh, how interesting. So there is actually effectively, there's three different types. You've got the sandy, which is very hard.
Yes.
And then you go for a slightly more softer version for stony, so it doesn't chip.
Well, it doesn't chip and doesn't break, but basically it's the lower. It's a different type of tensile strength. There's more elasticity in it, so if it gets a shock from a stone, it shouldn't crack.
Okay.
But the trouble is, if it goes that same part with that same tile goes into sandy land, it doesn't wear quite as good as the other one. That's the problem.
So then, but how would I know as a farmer?
In terms of what?
Whether I've got the tungsten for sandy or for stone?
We steer the middle course.
Okay.
So you don't have to choose.
Okay, yeah.
But say abroad where the general conditions, say in South Africa, are quite stony, we give them 90% of their land is stony, it's so dry, then we give them the stony type grade.
Okay, so it's a little bit more country based as opposed to area based. Okay.
Yes.
Understood. And then when he's done that then, he cools it.
Yes.
And you don't have to reheat to cool again.
No.
That's it.
You can see here, this is the localized area of heat. So and that's why we can see here the water line where we've kept it cool. that's where a lot of the wear happens when you've got the tiles on.
And you don't put anything on the side?
No.
And then this is going to get painted?
Yeah.
Okay.
Yeah.
So this would then go off in a batch off to the painting bay where we've already been. They'll do that and off it goes.
Yes.
Yeah. Why do you not do the sides? You've done the research and found that there's no benefit?
Because, that's how it ends up. But some customers will do something like that. Others have their own ways of testing, and in this particular case, they don't like anything on the sides.
So if I now went to hard face that in the workshop, would I then knock the tile off by the
Yes, absolutely right.
because of the heat?
Yes.
Okay.
I'd worry if you were doing hard facing.
I could ruin your
here.
10-year success rate.
Yeah.
Start telling you your tiles are falling
and then
off.
you send it back to us and say it's wrong.
And you go, what's that dodgy old stuff on the side? Yeah, got it.
When we temper, that's around 200 degrees. When you're hard facing, you're about 600. So it means you're tempering the whole of the bloody part back, or the area where you're hard facing. So what you gain is often what you lose.
Yeah.
That's the problem.
What is this part for?
This is for a Claydon drill.
Oh, is it?
Yeah.
Oh, Uncle Jeff, I call him.
Uncle Jeffrey.
Uncle Jeff, yeah.
In other words, when I say reverse engineering, it's this part here. It's for the aftermarket is a wing.
Yeah.
Goes into Germany, I think. And so we will scan this component that reads the shape of it.
Yeah.
And then we'll convert that into a model.
Yeah.
Effectively then starts to make the tool to bend that.
Yeah. It looks actually very similar to the part that goes on a horse Turano as a wing.
It's similar, but I think this one is a copy of the horse.
Yeah.
First.
So did you guys come off the floor?
I did, yeah.
Making in the forge, making things, and then made it into here?
I just come off the shop floor. Originally, before I came in here, I came off the shop floor.
Yeah. But you had a keen interest in design?
Yeah, I worked obviously at shop floor, then I moved on to the tool room, onto the CNCs.
Yeah.
And then got more involved in design, then came into design office.
Ian was just telling me that if you don't get the tooling right,
that's
you've
it.
just got a bad product from start to finish.
Yeah, definitely.
Yeah.
So this one that we're doing here, this is a swage tool for a new job that we're looking at. So what we do is we've done the model of this swage. Yeah. And then I export that as an IGES file.
What do you mean? What do you call a swage? What swage you mean?
Swage, I'd have to show you actually, swage of the part.
That's okay, just...
Yeah. So what we do is this is a swage tool of the part, and then what I do is I convert that into an IGES file to bring it into a different software.
Okay.
To machine it.
So anything that somebody wants making, basically, they would come here, and then you would draw it up.
Yeah, we draw it up.
And at that point, then you get the tooling made to suit it.
Yes.
Are you designing the tooling to do that? Then they go and make it physically.
Yes.
And then how do you measure what they've made? Have you got another scanning system which is scanning it to make sure it
we
matches?
have a scanning system, but you can just use the probes off the CNCs.
Okay.
To get the measurements of what we've done, you can do that.
And then after that, it goes into manufacturing?
It goes into development, so you actually...
you'll go and trial it?
Yeah, we're going to trial it on the press.
Yeah.
See if it needs any alterations. If the shape needs slightly changing, we can change that.
Yeah.
So what we do is change the DXF, get another one lasered.
Yeah.
And then the next attempt.
Okay, so it's actually a lot bigger than I imagined.
Yeah, that's 680. 30 mil of swage on a part. Obviously, you've got to have some clearance for your part to sit on here.
Yeah.
That'll go in the top tool, depending on which way you want to have your swage on what side.
When you talk about swage, you mean angles?
Yeah. I've got this is obviously formed. That is what you got on swage. It's more or less, it's different to a machine. If you machined it, but like I say, a lot of customers prefer the swage.
So you guys in here are just basically doing the design for the entire factory?
Yeah. Yeah.
So they're just checking that what you're doing is working out?
Yeah. What they do is they'll be able to look at this on graphics of the machine, and then they'll just look through the program to make sure everything's okay. And then what we do is machine it, and then we just check it with a probe to make sure all the sensors are correct.
Do a lot of you guys all come off the floor?
I come off the floor, Chris has come off the floor. Yeah. Bob originally come from in the tool room actually.
Yeah.
He was in charge of the section and that, and he's kind of moved up to design engineer as well.
So you can't just come straight into the design?
No,
you typically would come up into it?
Yeah, because obviously with your product knowledge as well, goes a lot better for you, because obviously you know how parts are made out on the presses, so as you're designing, you know which way is the better for the operator to get hold of the part and everything, and which way the tooling to go.
Have you got children coming into the business?
No, building business.
Oh, building?
Yeah, building, okay. So both of them into building.
Well, you're born and bred Sheffield?
Yeah. I've been around the world. I've worked abroad. I've worked in Bulgaria, Istanbul, and I came back to Sheffield in 1993.
Yeah.
So I've done a bit around the world, the razor blades actually. I used to be a razor blade technician.
What, for shaving?
Yes.
Really?
Yeah.
You were Mr. Gillette, were you?
Yeah. Well, we did have a competition with Gillette, and we actually won the big order off Gillette.
Really?
The size were a lot better, yeah. We were the first company to do the lady shaves back in 19...
We've all got a lot to thank you for then.
Yeah.
It's fascinating, Ian, quite frankly. I'm amazed in the individual time spent per product. In my mind, I sort of imagined it going into a factory, almost fully automated, popping out the other side, arriving at Spaldings, turns up at the farm. But there's individual people have actually had a very key part. And because of the longevity of your staff,
yes,
they are, you know, you could almost name these pieces, couldn't you, per person? Yes. But when it turns up, I say, oh, Ted did that, you know.
Well, certain operators are very good at doing certain things.
Yeah.
So the computer keeps lists of everything everybody makes.
Yeah.
So now it automatically puts them on the right operator onto the right path.
Yeah, and then, I mean, you've got 3 shifts here as well.
Yes, 3 shifts, doing the night shift. Not quite weekends.
No.
Too expensive.
What, for overtime?
Yeah, we have to pay them double time on Sundays. So that doesn't
and
work.
You've got to be on call as well, so you've got to have some time off, haven't you? Yeah.
Sundays I dare rest, actually.
Is that right? Yeah. You're asking forgiveness.
Yeah.
But,
it's been a long day.
Yeah. Well, it's been very good. You know, I'm very grateful for the time that you've taken to show us around.
Pleasure.
And I think the most amazing thing is about all of this is getting the opportunity to go behind doors of parts of the industry. I think that we probably, certainly from my perspective, take for granted and don't really actually see the processes going on from the design right through to the tooling to then actually seeing it. There's so much going on in this industry, far outside.
There's a lot.
Yeah.
There's a lot of know-how, a lot of experience here, a lot of knowledge, a lot of support in the city.
Yeah.
And we're very lucky to have that, frankly.
I think actually Sheffield in itself, the skills, you couldn't set this foundry up, for example, in Cambridge.
No, not really.
You wouldn't have the skills and...
No, you wouldn't.
No.
And you might not even get the people to work in the factory.
Yeah.
That's the
no,
other
I don't think you would.
But no, we're very lucky. We're very conscious of that, and you know we are part of Sheffield heritage. Yeah, I'm very proud to be part of that.
Yeah, and Lady Riverdale, as I saw on over there, there's a big stone, so she opened it in 1945. Yeah. So we must thank her.
Yes. Well, we've named the forge after her. It's the last new building we put up. So we call it the Riverdale Forge. Yeah. And very proud to do that.
Oh, thank you. Well, thank you, Ian. Appreciate it.
Thank you very much, James. Really nice to meet you. Thank you for your time and coming around.
I'll load the boot up while I'm here.